Welcome back to Hands-On Science. On Hands-On Science, we're doing fun activities and experiments to learn about God's amazing creation. Today, we're going to be continuing on from our last video about our atmosphere. So if you haven't watched that yet, I would suggest watching that video first. You can find the link to it in the description below. If you remember from our last video, the air in our atmosphere is made of tiny molecules that are bouncing around, full of energy. The force of these molecules against our skin and everything else on the planet is called air pressure. Now it's hard to imagine something we can't see having so much force on us, but we're going to do an experiment to see it in action. For this one, all you're going to need is a sink full of water and a glass jar or drinking glass. So I just colored the water blue so we can see it a little better. So you're going to take your jar or glass and stick it in the water. Make sure it's all the way under the water. Try to get any air bubbles out of there. And then flip it upside down. When you pull it up, the water stays in there. So the pressure of the air in the room is pushing on the water, holding it up inside the jar. Now gravity, of course, is pulling down on the water, but as the water starts to go down, that little bubble of air in there starts to expand slightly. The air molecules start getting farther apart and creating less air pressure. So there's 14.7 pounds per square inch of air pressure pushing down from the outside, but less than that on the inside. And it's that difference in air pressure that's holding this water up inside this jar. Alright, we're going to take this experiment a step further now. We're going to cut out a piece of cardboard from a cereal box. Make sure the cardboard is bigger than the mouth of the jar we're using. And we're going to fill the jar up with water till it's overflowing. You're going to want to make sure you're doing this in a sink. Alright, so now we're going to pick up the jar and set the cardboard, shiny side down, on top of the jar. Some of the water starts to leak out a little, that's okay. Alright, so we're going to hold the card down as we start to flip over the jar. Alright, now we're still holding the card on, of course, and so of course the water's staying in. But what will happen when we take our hand away? Let's find out. And the card stays. And once again, air pressure is holding the water up in the jar against the force of gravity. You may remember that air pressure at sea level is normally 14.7 pounds per square inch, but air does not always stay the same pressure. Air pressure changes with weather and temperature. Low pressure air usually means stormy weather, while high pressure air means there will be clear weather. You can measure air pressure with something called a barometer. Alright, so we're going to make our own barometer. For this we're going to need a jar and a balloon. We're going to cut the neck off of the balloon. Alright, and then we're going to wrap the balloon around the mouth of the jar. Alright, so I don't think I cut off enough of the neck of the balloon, so I'm going to cut off a little more. Let's try it this time. Okay, so it looks like I'm going to need a little help with this. Stretch it real tight. There we go. Now there's no bubble on top anymore, so that's good. Alright, next we're going to take a stirring straw, or you can also use a toothpick. And this one's a bit long, so we're going to cut off about a third of it. And then this is what we're going to use on the barometer to tell how much the pressure is changing. And so we're going to need it pointy at the end, so we're going to cut on an angle right at the end. So we have a nice point there. Alright, so next we're going to glue the pointer onto the balloon. We're going to glue it about the center, but put it off a little bit from if you have a little bump in the balloon. So put a tiny dab of glue on the balloon. Okay, and then we can put the straw onto the dab of glue. Alright, you're probably going to have to hold it there for a little bit for it to dry. Alright, so while this is drying, we're going to set this aside and make something that will help us keep track of the changes in pressure. So we're going to need a jar or container that's taller than the other jar. So we're going to take some masking tape, get a nice long strip, and we're going to put that on the side of the jar. Make sure it goes all the way up to the top there. Alright, so to use the barometer, we're going to set the barometer right next to the other jar, and the pointer on the barometer will point to a spot on the tape here, and we're going to mark that down with a marker. And so go to the tip of the pointer and mark right there. So we're going to watch this over the next couple days and see if the pointer moves. So what will happen is if the air pressure gets higher, it's going to push down on the balloon and make the pointer go up. And so we'll see the pointer go up if the pressure goes up. Now if the pressure goes down, if there's low pressure, then the balloon's going to be kind of pushed up from the inside, the higher pressure air inside, and the straw is going to go downward. So pointer goes up means higher pressure, pointer goes down, it means lower pressure. Another thing that affects air pressure is temperature. Remember that air is made of molecules bouncing around. The hotter the air molecules are, the more energy they have. If you heat air up, the molecules will have more energy and bounce around faster and start to move away from each other. In other words, if air heats up, it expands. The opposite happens if you cool air down. The air will shrink. Alright, for this experiment we're going to take a 2-liter juice or soda bottle and a balloon, and we're going to wrap the balloon around the top of the juice bottle. If you remember from our last video, we actually did an experiment similar to this, but don't worry, this is a different experiment. So I took 2 buckets and filled them up. You can also use a kitchen sink or ice cream pail or whatever you have lying around. So one of them you want to fill up with hot tap water, and the other one you want to put cold tap water and put some ice cubes in there if you have some. Alright, so we're going to take our bottle with our balloon on top, and we're going to stick it in the hot water. So stick it down in there so that the water surrounds it. And you'll notice the balloon is starting to blow up all on its own. That air inside is warming up from the hot water and starting to expand. So now we're going to take the bottle out of the hot water and we're going to stick it in the cold water this time, and we'll see what happens. The balloon is starting to shrink. The cold ice water is cooling down the air inside, and now the air is starting to shrink. The balloon's getting pretty flat there now. I'm going to pick it up a little. Now it's even sucking the balloon inside the bottle so that it can, there we go. The air outside is actually, the pressure is pushing that balloon down in there because of the air shrinking inside the juice bottle. We're going to try putting it back in the hot water, and the results will probably be a little more dramatic this time since it's inside the bottle now. Air is warming back up and popping back out. There we go. So the hot water heats the air up inside the container and it expands, while the cold water cools the air down and makes it shrink. Did you ever wonder how hot air balloons fly? Well, when the air heats up inside the balloon, the air expands. It becomes less dense than the cooler air outside. That means that the hot air in the balloon weighs less than the cool air it pushes away as the balloon floats through the sky. It's similar to pushing a beach ball under the water. The beach ball is much less dense than the water, so it pops back up and floats on top of the water. Warm air is less dense than cool air, so it rises above it. Now, I don't happen to have a hot air balloon lying around to show you guys how this works, but I do have something else that doesn't even need you to heat the air up inside it. It uses the heat from the sun. I'm here with my friend Dino Mo, and we're going to be using the energy from the sun to fill up and float a huge 60-foot long solar tube. So let's get started. Absorbs the sun's heat and warms up the air inside. The heated air expands and gets less dense, making it lighter than the air around. The heavier air outside pushes the now lighter bag upwards into the air. Did you know that the sun causes wind? Just like with the air in the solar tubes, the sun heats up the air at the Earth's equator. The warm air rises, starts to cool down, and then sinks back down in a cooler place. The air keeps circling around, creating Earth's wind currents. Explorers and scientists discovered this process several hundred years ago, but it turns out the Bible described it long before then. The book of Job states that light scatters the wind on the earth. The light, or electromagnetic radiation from the sun, is what heats up the earth, causing wind. And Ecclesiastes 1:6 describes how the wind travels in circuits. God knew how wind works long before man did because, of course, he created it. Not only that, but the winds also obey his voice. When Jesus was on earth, he was once in a boat with his disciples. There was a big storm and the disciples were afraid that they would drown. But Jesus simply told the wind and the waves to be still, and the storm stopped. The disciples couldn't believe it and wondered who this Jesus could be that even the wind and the sea obeyed him. But Jesus knew that they never had to be afraid in the first place, no matter how big the storm was, because in their boat was Jesus, the creator of the world and the master of the winds.